Hi, Josh. We'll be doing three problems in geometry. So let's start with this number one. Radius AO is perpendicular to radius OB. MN is parallel to AB, meeting AO at P and OB at Q, and the circle at M and N. If MP is equal to square root of 56 and Pn is equal to 12, find the measure of the radius of the circle.
Okay, so okay, so OB is AO is radius and OB is a radius. So OA is a bit. I will just use the blue pen. OA is equal to is congruent to OB. Okay, so then AOB is AOB. I just put vertical. AOB is
Yes.
then if AOB is isosceles, then angle A, there's only one angle A. Is there? And oh no, actually there will be another angle A maybe. So OAB is congruent to angle OBA. Yes, okay.
Yes. So you
So I
can
will
put
put
marks
here.
here if you want.
Here,
Yes. This one and this one. Yes.
here. So since MN is parallel to AB as shown in the figure, use alternate interior angles. So angle angle MPA is congruent to angle PAB or OAB. This really matter for the reason. Because MN is AB.
Yes.
And then
Alternate interior
similarly,
angles. So you can even put marks if you want.
yes,
That
wait.
red.
Similarly, uh, NQB, yes, NQB is congruent to angle OBA.
Yes.
So is
You
it?
can put marks. Those are alternate interior angles.
Because these are congruent. Either they are parallel. Okay, so because again, MA is
Parallel to
AB,
AB.
therefore isosceles angle
Definition of
AOB is isosceles. Therefore, angle
so
already I am equal. Okay, so transitivity by transitivity, since OAB is congruent to OBA, then angle MPA is congruent to angle NQB. Actually, it's already shown in the figure because I placed the same marks. So this red angle is also equal to that red angle.
yes, all four angles
All four angles
are
are equal.
congruent.
Then the key point there. So this I can really move it. Mm, It's hopeless. Okay, so MPE is NQB. So maybe I will start constructing a line. Construct first here.
You will create a triangle there, yes.
Yes. Yes. So construct AM and BN to form triangles
Map
map ends
QBN.
QBN. And then uh since
You can transfer this.
yes. Wait. So since this is PAQB is a trapezoid, since those two PQ is parallel to AB because PQ is part of MN, which has been defined as uh which has been defined as parallel to AB. So PQ is parallel to AB. So PAQB is a trapezoid. And since PAB is congruent is yes, congruent to QBA, or equivalently here, no, not the MPA. OAB is congruent to OBA. So PAQB, but trapezoid, PABA, PAQB is isosceles if of isotrapezoid. Okay, so now that this is isosceles, the consequence is that PA is congruent to QB because, of course, that's the definition of the isosceles trapezoid. When the base angles of any trapezoid are the base angles, yes, there's no other term for it. The base angles of a trapezoid are congruent, then it's isosceles. So that consequence is the two non-parallel sides of the trapezoid are congruent. PHQB. So we have, where is it? Here, here, maybe it's a different color now. PAQB. Is it visible?
Yes.
Okay. Uh, so we have SA of the triangles MMAP and QBN. We just need another one. So we'll move to the next page. I'll just go back. Oops. There. So first, since MP is parallel to wait, are we sure? Okay. Since MN is MN is parallel to AB, then the intercepted arcs MA and BN are congruent. Okay. M MABN.
So, okay, let us see the figure. AM is congruent to
BN. That is because
y.
if tangent or chord is parallel pa- to a secant or chord, then the intercepted or subtended
Intercepted arcs are,
arcs are congruent.
yes.
Okay.
So arc AM
Since yes,
going to arc BN.
since AB is congruent to itself, AB is congruent to itself. Arc AB is congruent to itself, obviously, because it's a reflexive person. Reflexive property of anything.
Of congruence.
Then what is that? Another there's a theorem I forgot. Uh, when something, let's say,
Arc addition.
I'll just put yes.
Arc addition.
Addition theorem is it
Yes.
MA plus MA plus AB, so that's MAB is congruent to BN plus AB, so that ABN.
So
Actually,
show the angle addition.
yes, yeah. So here, MA AB to
SBN.
that is like okay. So it's hard to see. Maybe it is hard to see, but AM AMN is um is an ascribed angle, and similarly,
Angle A.
yes,
A.
angle AMN is an inscribed angle, and angle MNB is also an inscribed angle. It's just a little hard to see because NB
You
is
can
so
put
small.
a dotted line if you want. You can use different colors.
Small. It just looks like this. It looks like that sort of, and then this one also looks. I mean, no. So M and B sort of looks like this if you exaggerate it.
Okay.
So now that if you see it, any two or any number of intercepted arcs, intercepted angles are congruent if they intercept the same arc. So here M AM arc angle AM and subtends or intercepts arc ABN. Right. I'll just put the statement and now I read the explanation. Mhm. So I will explain. Arc
So that
A
angle.
yes.
You put mark
AMN.
different color like.
Ah yes, wait. So
Sa iba kulay.
something more contrasting maybe.
Yes.
Actually green then. Green is
Light green.
I
Yes.
can't see the difference much of green.
Yes, but we can. Your viewers can. So those two angles are congruent because they subtend congruent.
Yes.
Arc.
Put it. So AMN. AMN intersect intersect intercept. What does it intercept? ABN. Yes. Arc ABN. Similarly, mm, MNB intersects MEB. And since MAB is congruent to ABN, actually, it doesn't have to be intercepting the same arc. It just has to intercept the a congruent arc.
Congruent arcs. They're intercepting congruent arcs.
So if
Or you can just put inscribed angles intercepting congruent arcs are congruent.
okay. Okay. So we have angle side of MAP and QNB. So that's enough to deem them congruent. Angle, what's that?
Triangle. Map.
Triangle map and triangle. Yes, QNB. Yes, QNB.
You.
B because of SAA.
Yes, a congruent.
Congruence. Uh, yes. So now we will start using the measures instead of just proving. So if MAP is congruent to QBN or QNB, then we can conclude by CPCTC, MP is congruent to MP is congruent to QN. This is because of CPCTC. Yes.
Congruent parts of congruent triangles are congruent.
So if MP is square root of 56 and PN is 12, so we can find QN.
You can put on the.
I can put that because
Okay.
the PN is intersected.
Okay.
So we can find PQ. Oh no, actually, since we already know QN, I will just this one. We can we'll put a guide and then I will put dotted lines. Guide. Look straight. So if we continue AO, then it will hit a point. We can call it C. Yes. So AO, if we extend it, it will hit C. So if O is the center, it's a diameter. But AO is a chord. Similarly, MN is also a chord. Okay. So MP is square root of 6. And then PN is 12. AP and PO. Yeah.
P
OP.
is equal to A.
Yes.
Put there A.
Mm,
Use green or something. That is AOP.
And A, that's not A. A is OP.
So
So,
OC is
yes. OC is, actually AP, let it be, no, actually OC is a different unit.
what is it?
Let's let
OC is the
OC be the radius.
yes, it's the radius.
So then AP will be A minus the radius minus A.
Yes.
Okay, let OC radius equals R. Then AP.
AP is equal to
R minus E.
radius minus 3. Yes, minus.
Now by using the intersecting chords, since intersecting chord theorem, AP times PC, AP times PC, EP times PC is equal to MP times PN. Okay, so AP over PC, AP times PC. PC is A plus R, and R plus A. AP is R minus A. R minus A times R plus A is equal to, what happened?
This is
And
minus theorem.
intersecting chord theorem. Intersecting intersecting chords. I forgot.
Yes.
PN is what? PN is 12 and MP is square root of 56. So this is 12 square root of 56. Okay. So OP. So here we're going to use the fact that we were able to find, we were able to find MP is congruent to QN. So
Yeah.
but
MP what? Sorry.
MP is congruent to QN.
QN.
Yes. So this will be PQ. PQ. So we will find PQ. PQ. Actually, so
PQ, yes. PQ.
I forgot to put earlier. Since MN or PQ, because they are part of the same line anyway, it is congruent to AB, then angle PAB or OAB is congruent to OPQ. I'll put that here. OAB, OPQ. Yeah, OAB, OPQ, yes, PQ. And then similarly, angle OBA, angle OQ.
Can we check on the figure?
Yes, this is because MN is parallel to E.
Which angles are those? O.
OAB. Wait,
O.
that's why I should have made the small
Yes.
angle. Useless. So I will just put it here. Red. There. So again, like earlier, uh, those are base angles of an isosceles triangle. So OPQ is
Those are corresponding angles. Huh?
no. Ah yes, they are corresponding angles. Yes. Therefore, an isosceles triangle.
So they are corresponding angles.
Yes.
Parenthesis isosceles triangles. Angles. By
Corresponding
corresponding.
angles.
Corresponding angles. Corresponding angles.
Yes. So OPQ is isosceles. Similarly, like earlier, OP is congruent to OP. It's congruent to OP. Yes. So, OPQ is right. Wait, where is it? OPQ is right. So, if any right isosceles, the only right isosceles is 45, 90 triangle. Is right. OPQ. Mm, mm, yes. No. And
Negative triangle. Yes, isosceles right triangle.
right isosceles. So, any 45, 90 triangle has dimensions 1, 1, square root of 2.
Yeah.
Okay. So, um, MP is congruent to QN. MP is congruent to QN. And then we know PN. So we can find PQ. Because MP is congruent to QN. Wait, no, no, no. Here, MP is congruent to QN. Then QN is equal to MP equal to square root. This needs no more explanation. So since we know what Pn is, we can find PQ. PQ is equal to Pn minus Qn. And then substituting, that is 12 minus 56. Okay. So we will use that here. Since OPQ is a 45, triangle, we can find OP. And the thing here is that we will need OP. Wait. So our current situation here is we have two variables. Here we have two variables, R and A, and then we have a value. So if we can evaluate one of them, of course R is being looked for, so we can find A more easily, and then we will find R that way. Yes, A is equal to OP. So if we can find OP, which we are about to happen, yes. So is equal to OP. What? Which one?
OP.
OP is equal to.
Right?
Yes. Therefore, OP is equal to OQ. These are the measures of OP and
Is
OQ.
equal to. You said the measure is equal to A.
Yes. Equal to A.
Just for them to see.
So, uh, where are we? There. PQ is the hypotenuse of the 45, triangle, OPQ. So therefore, by using the dimensions OP or A, OP or A is equal to, wait. So to show this is A, this is A, This is what we're looking for. And then this, the square root of two dimension is 12 minus square root of 56. So therefore, A is equal to 12 minus square root of 56 over the square root of 2. I'm not going to rationalize anymore. We're going to square it anyway. Because here, this is actually, I forgot to write. This r squared minus a squared, the difference of squares. So we're going to square it anyway. There's no need to rationalize it.
Okay,
So OP is 12 minus square root of this over square root of 2. But you would must be uh r squared. Where's my pointer there? R squared minus a squared is equal to 12 square root of 56. Now we know that a is 12 minus square root of 56 over square. Then if we square this, now we only have one variable, and it so happens that one variable is radius. The radius
Yes.
r, so we can find r.
So this is algebra.
Yes, algebraic fields. So r squared. This is just algebra. So the bottom two, the denominator is two, and then 12 minus square root of 56 squared. Where is it? Oops. 12 minus square root of 56 squared squared is equal to 144 squared. The first minus 2 times the product of both. So 2 times 12, 24 square root of 56. And then the square of the last second term, yes, that's 56. So this is
Plus 56 equal
144 plus 56. Okay. Uh, 9. Wait, square root of 56 is square root of 56 actually is can be simplified. Square root of 56 is square root of 7 times 8. So that's to be better. That is 14 times 4. So that's 2 square root of 14. So this is equal to 200 minus 48 square root of 14. Okay. So 200 minus 48 square root of 14 is equal to, so now we know it's 2 square root of 14. 24 square root of 14. R squared is equal to 24 is minus anyway, so it will be plus here. Plus, we've simplified already. 200, 100, 100 minus it's plus anyway.
So this one.
What?
Don't skip a method. So
No, I just simplified it.
okay.
100 minus 24 square root of 14. Hey, magic. So it appears to be magic. Somehow, this is square root of 24. This is square root of 24. So they cancel.
Yes.
So somehow r squared is exactly 100. Since r cannot possibly be negative, r must be equal to 10. It cannot be negative 10 because
so
there is no negative.
So this step.
What?
Compare features with R is
Plus minus 10. But since 10 cannot possibly be 10, the r cannot possibly be negative 10 because there's no negative dimension. So r is equal to 10. The radius.
Yes. Nice.
Yes. Good.
You can follow the shape of
Victory yellow.
R is equal to 10. Yes.
Yes. We can move. So this is number two.
Problem number two, find the area of there is a rectangle. So given a rectangle, so can you put there?
Just given a rectangle.
Given,
What?
just write given rectangle.
Oops. There's no space.
Below, yes,
Given
rectangle.
rectangle.
Okay. So the rectangle has been divided into four triangles. The three triangles have been given
Areas.
the measurement of their areas. There's 35 there units, square units, 21 square units, and 28 square units. Find the area of the middle triangle, the one with the triangle with a question mark.
Okay. So to solve this, I will first be because it's
Assigning. You can assign something.
so far we only have areas, so we have to assign variable. So this is A. Since this is a rectangle, the other side is also A. So this I will set this as B. Uh, wait.
And that is A, and this is B.
Uh, B. Ah, nice. Okay. So this is B. And then this entire side should be A. So therefore, this is A minus B.
Yes. Okay.
Okay. So a very important fact about triangles is that we will be using probably extensively here is the area of any triangle is equal to one half the measure of its base times its height.
So the triangle is equal to one half base times height.
So first we will start with the biggest triangle, which is area 35. So where is it? 35 is equal to one half base. Let's use the A as base. Since this is a right triangle, the height must be the other leg. If the one leg is the base, it must be the other leg. So the other leg, let's call it 8 because we haven't found the other one, the other heights. So H is equal to 70 over A. 70 over A. Next triangle will be the second, no, will be complicated. 21. 21 is equal to one half B8 prime. So we will have confusion with the H's. So H prime is 42 over
You can put here each.
70 over A.
Yes.
42 over B. I'll just write it like this.
No problem.
Okay, so 70A. Yes, so that's our triangle, which the 28 is equal to one half. And maybe I'll put it lower, it looks confusing. 28 equals one half A minus B, each double prime. So therefore, each double prime is equal to 56, 56 over A minus
A
B.
minus B, yes.
I'll put here, this is 56 A minus B. So since this, again, this is a rectangle. We can put this dividing line.
Yep.
Uh,
You can use different color for your dividing line if you want.
so, mhm. Okay. So since this is a rectangle, uh, two opposite sides of the rectangle will be equal. So 56 over a minus b, which is one of the sides, must be equal to the sum of 70 over a plus
So
42.
opposite sides of a rectangle are congruent or have equal measurements.
So we can factor this. Just make it smaller because big numbers are hard to deal with. Okay, if we square them, it will be hard to deal with. So 14.
Factor is 14, so multiply by 1 over 14 both sides.
So 4 over a minus b is equal to 5 over a plus 3 over b. And then, uh, 4 over a minus b is equal to, put them under a common, since the left side is, as much possible, if you have some or different of fractions, put them under a common denominator. So if there's another single denominator on the other side, or there's none, just make it into a common denominator so you can remove the denominators because fractions are evil. So 5b b cross multiplication plus 3a, and then all over its common denominator, which is a. Okay, so now cross multiply, as I was saying earlier. Now it will be easy to cross multiply. 4 times ab will be equal to 5b plus 3a times a minus b. I'll just put one last equation here. It will still fit. So 4ab is equal to this one. So we will just expand. What's that? Foil here. Foil. 4ab is equal to first 5ab. What? Ah, yes. Magic. Oh, there. Yes. So
Applying some magic there.
5ab outer inner, minus 5b squared plus 3a squared, minus 3.
Yes.
Yes, okay. So we have a lot of common terms here. This is 5ab and 3ab. This is just 2ab, 2ab. And then this 4ab, we can transpose it. This is 2ab minus 4ab, negative 2ab minus 5b squared plus 3a squared. Next page, of course. So,
So just
wait, I will just rearrange it now. Uh, 3a, so it looks cleaner. 3a squared minus 2ab. No, no. Actually, it's minus 5ab. Minus 5b squared. Sorry. So, now, this will be most of the time when you do something, you want to simplify it. Every single common factor will be merged. Actually, maybe
rewrite this one. The next.
yes. Okay. Okay. 0 is equal to 3a squared. What's this? Minus 2ab. Minus 2ab minus 5b squared. So now, instead of making it simpler as possible, in order to factor things out, I will make it bigger. 3ab minus 5ab minus 5b. So now 5b squared. So now if you, yes, I just expanded it. Expanded the 2ab into 3 minus 5.
2ab. What happened to 2ab? Ito, that variable, so
I will need the space with
minus 2ab.
here.
What happened to the negative? Huh? Yes.
Factor. 3a can be factored. Actually, good because there will be a minus 5a, 5ab. And similarly, it's also negative 5b squared. So it'll just be some factor minus another factored expression. 3a can be factored out. 3a plus 5b, a minus b. Nice. So we what?
A minus
Sorry, a plus b.
plus.
So they are technically, if we think of a plus b as one variable, then this will be like terms. So 3a minus 5b factored out times a plus b.
Yes.
So if this is equal to, yes, actually, if this is equal to zero, then zero can be either, but not both of them. Either or both. It's an or function. It's not, so a plus b is equal to zero. Then yes.
A there will be,
So a will be equal to negative b, which is impossible because first of all, a is bigger than b, and second, a cannot possibly be negative. If b is positive, then a will be negative, and if b is negative, to make a positive, that's also impossible because there's no negative dimension. This is a dead end. This is an extraneous. It's not technically a root, but it's extraneous. So 3a minus 5b is equal to 0.
the extraneous root for
No, it's not.
that
It's,
equation.
it's technically
For
not a
A.
root because we don't have any value. It's technically not a root. So 5b over 3. So here we had this with this. Yes. We have this h prime is equal to 56 over a minus b. That will be useful because 56 over a minus b is the another side length. If we have a, we have another side length, which is 56 minus a minus b. So we'll just rewrite it by substituting in the oh wait, maybe it will be better to use. Hmm, B. B, 5B. So B will equal 5B, 5B3A. So 3A over 5. I realized because we have one sign less that is A, it will be better to rearrange it in terms of A and not B. So we can multiply them and get an area in terms of E. B 56 over A minus 3A 56 over 5A minus 3A over 5, or 56 over 2A minus 5 up to A over 5. So this will equal to 5 times 56, 240 over 2A. Thus, this is 120. Oh, wait. This is hmm, 250, 280. Yes, 280 over 2A. So this is 140 over A. Now we have A as a side. So it's very convenient because 140 over A will cancel with
equal to 140 over.
with H prime.
So put here, can you put on a figure so that they will make it better understand?
Right.
We can put here. This is equal to
And then the area of a rectangle, an area of rectangle is its width times height. So in this case, that is 140 over A. That's the width times height, which is actually A is the width, and then 140 over A is the height. Doesn't matter. So this will just cancel out. This, this one. This will cancel out, and then we have 140. So
that's the area of the whole
rectangle. So the inner triangle, what do we call it? Let's say we call it triangle 4 because all the others are 1 to 3. So this is 140, the whole rectangle minus each of these areas, which is 35,
21.
35 minus 21 minus 8. So this is 56. So this is our answer. The area of the fourth triangle is 6. So actually, I will show another
Square units.
yes, 56 square units. I will show another branch. Wait. So move to the next page.
Or you can continue there. So,
Mm,
you want to continue or
okay. So what is it? I'll just use a different color so it will look different.
lighter green.
Let me be- so here we use the fact that the sides, the height of the rectangle will be equal on both opposite sides.
The left side is equal to the right side of the
Yes. So the left side will be the sum of those two, 70 over 8 plus 42 over 9. So this time, we will use a different method, which will be the rectangle. Yes, the area of the rectangle is, of course, equal to the area of the rectangle because reflexive. So the width of the rectangle, the width of the rectangle is still A. So here, we will use one of the sides, which is 56 over A minus B. 6 over A minus B times A is equal to 70. Oh, it looks like 2. 70 over A plus 42 over B times A.
Or instead of using the A for the other one, can you go to the figure? Yes. Use the other
Well, we'll just end up with
side.
A again anyway.
Yes.
So it's equivalent.
And then the A's will
So,
what happened to the A's?
yes. So the A's will cancel anyway. So, oh wait, I'll just put to the next line. It will be confusing. So, 56 over A minus.
You could have combined already what's
Okay.
70 over A plus 32 equals B.
AB. B 70. 70 B plus 42 A. Actually, now that I realize, it's exactly the same as we did before.
Yes.
You just did not factor it. So eventually, I hope this will factor. 56 EB is equal to 70 B plus 42 A. Yes. So we just did not factor it by 14. So this must end up the same. It just has 14 as an extra factor. So we were at 56. Where am I? Okay. I was at the very edge. Let me see. So 56 over A minus B is equal to, wait, we were already at AB. 56 AB is equal to 70 B plus 42 A. 70 B, 42 A
Times A
times
minus
A
B.
minus B. So that is 70 AB minus 70 B squared plus 42 E squared, and then minus 42 AB. Combining these like terms similarly as before, just different a little because we didn't factor it. 70 minus 42 is 28 AB. And then this one is 56. So we can bring it to the other side. 56, 28 minus 56, but it's negative 28 anyway. So 42A squared minus 28AB and then minus 70B squared is equal to 0. Again, we can just factor it. 14 times 3A squared minus 2AB minus 5B squared. Then this will cancel, of course, because it's there. So finally, it factored out. So it will end up, where is it? It will end up like this.
Like this. It's the same.
It's the same.
We'll continue as that like that, and the answer will be the same.
56. So our last problem. This is given angle QSP is 21 degrees.
So you can put it, then put on the figure.
Angle QSP 21 degrees. Angle QSR 34 degrees. Yes, wait. Maybe it's too in it.
If I were you,
Yes.
so it would be up. They're the same form.
Yes, I will just change it later. PRS was PRS. PRS 77 degrees. So this will be uh,
Those are the given. So is QS a diameter?
Okay. So maybe we could find every single possible thing we can find here.
Yes, so that is
So wait.
for
Yes.
exercise in geometry.
PRS intercepts PS, so does PQS. Wait, I'll just put it there. PRS is congruent to PQS. They intercept the same mark, which is PS.
Close, close to the body.
Yes, PS. I can actually put the equal set. So is equal to 77.
Then we can label it. 77. We subtend the same. Like
Similarly, oops, similarly, similarly, mm, uh, QRS is equal to measure of QP or yes, QPR.
Yes. Uh,
QSR, sorry.
the given
QSR.
just the given
No, I did not see that it is QS. QSR, QPR. They intercept, they intercept QR. So this is equal to 35 degrees.
So you can already equate to the
34 degrees. And then similarly again,
okay. How about the missing QP R
RTS.
RPF? Yes.
Oh,
Or
hmm. 77. Wait. So there are two ways we can do this. One is, wait, one is QTSR, P, uh, PQRS. PQRS is cyclic. So QPS, therefore QPS plus QRS is equal to 180. These are the measurements. So QPS is 34 plus missing angle plus 21 plus 77 is equal to 180. What's the calculator?
sorry,
The calculator.
it's not here.
What's the 180 minus 77 minus 34? I get into the 180 minus 77. 40. Therefore, x is equal to 40.
For 2 degrees. So you can put there on the figure, and then you can calculate the
What color? Like blue. This will be 40.
N, which is equivalent to because they subtend the same
Yes, similar to earlier.
RS.
So another property of cyclic quadrilaterals, every
You
other
can put also
yes.
the values of the arcs.
48 wait. 21 first is one half.
QP is what?
QP is 42. That's 2 times 21.
Yes,
42 degree. Now 40.
QR.
QR. QR is 34 times 2. That is 68 degrees.
Yes.
And then RS is 48. So 96.
Yes. And
So
PS.
PS is 77 times. So okay, so that's 154.
Yes.
So to check, there are two ways if we get to check that this is that if
FQS.
QS is a diameter. First is the RQPS. Actually, any RQS, minor or major, because it doesn't really matter. There isn't any minor or major for a 180-degree angle. Must be 180. So 40 is 42 plus 154 is 42. Is 42 plus 154 equal to 180? The answer is no, because
No.
42 plus 154 is 196.
Yes. So
Okay, so it's immediately not. But anyway, there's a
QS
second
is
way.
not
Yes, it's not diameter.
diameter because arc
Or QPS.
QPS is what more than 180 degrees.
And then the minor RQF is less than 180 degrees.
Yes.
So there's another way. In the if imagine if we did not find this. So if QR for any semicircle, any possible inscribed angle in the circle will be 90 degrees, because it's if the inscribed angle is one half of the intercepted arc, so one half of 180 must be 90. So immediately we should we can try 21 plus 177. Is it equal to 90? No, of course the answer is no. It is 98. So
21 is 77, yes.
yes.
So
So it's not
that
90.
is angle QRPN plus PRS.
Yes.
So this is
So QS the diameter.
because in any um, can you make a small circle?
What's most circle?
Any small circle. A small circle.
Small circle?
No, a small circle.
Ah, okay. Mm.
Just put it there. If this line is a diameter and any inscribed angle within the semicircle should be equal to
Yes.
90 degrees.
Because
So,
it's straight angle. So the
or,
inscribed angle is one half the
or
straight
on the
angle.
other side,
Should also be
should also
90.
be 90 degrees.
We have another way pala. So 34 plus 48 must equal to 90. But
Which is
30,
not.
but 34 plus 48 is 82
82.
degrees. So it's not.
So that's it.
Unfortunately, it's not the diameter.
So, your answer?
No, it's not the diameter.
No, it's not allowed. Hope you learned and you enjoyed the solutions of Joshua. Thank you very much.
Thanks.
Thanks for watching.
For watching.
Fun.
Thanks.